so you're live.
Okay.
I'll just ask if there's another lightning talk after.
Yeah, ask.
All right, this is another lightning talk of 5 minutes. Is there another one that wants to queue up after this talk or not? Yeah, just a few minutes, then you can.
Okay.
Okay, let's go.
Okay. Hello, hi. Wanted to talk about a small project that was very useful for me. I had the problem with to get out-of-band management out of a router, an OpenDBT router. That's typically have a serial console over 3.3 volts. And I thought about using Wi-Fi to extend that console and accessing it remotely. So I used the ESP8266 board, where I used a firmware called G-Link, made by someone, a community and a company in Holland. So see, this is an OpenDBT router with 3 wires, one for ground, one for TX, one for RX, and the ESP8266 board. So the firmware is from G-Labs called ESP Link, and it has a nice web interface where you can specify the baud rate that you want, and there's also a nice GUI for the Wi-Fi, so you can scan the Wi-Fi, choose your access point, put your key, I want to connect to that one, everything through the Click Home. So one interesting thing I did was to telnet, so you can telnet to the IP of the ESP on port 23, and then you get the serial console out of that. There was some option where I had to pass these mode characters, otherwise the back was not working. What I also did was I wanted to have the serial console, but transfer it to my laptop, so that my laptop would see a /dev TTY USB 0. And then I used the SOCAT option. So SOCAT STDIO TCP connect to the IP address of the ESP. And then the second option is SOCAT PTY and then link to /dev vmodem 0. So vmodem 0 is the new dev entry I want to behave as I would have a standard serial port on my laptop. Put some wait slave and then specify the IP address of the ESP8266. And then I could do a screen over this serial interface and have the console as I would have had with a normal USB to serial adapter. One thing I also experimented with was to send files with a Python program called seraio.py, where you do seraio.py, the file, the destination, and then the dev entry. And it took, in timings, I did for 100K file, it took 8 minutes. So this is 1.2 kilobyte per second. A 1 megabyte file would have taken 85 minutes, or 1 hour 25 to complete. But there are ways to specify higher baud rates, but that needs to be, the target needs to be configured. One thing I wanted to do was a commercial device, take an ESP in the right form with some kind of headers that you can choose with the jumpers, all the combinations possible with the pins. And then normally on, let's say, OpenDBT routers, you have 4 pins, the VCC in 3.3, the ground, the TXRX, and have directly an ESP on there connected to that. And then furthermore, have some kind of server device, some cloud stuff where I could send this and optionally also even encrypt it so that on the other side you could connect to the server and then have a console back to your device. So that's pretty it.
All right, thanks.
Yeah.
Again, if there are questions, please see Benjamin outside. So we have a few minutes until the next talk.
So who is it?
Who is it? Alvaro should be here somewhere.
He doesn't know, but actually it's just not findable.
The room?
Yes.
Yeah, I know, yeah. And also, it changes every year, so.
Yes, exactly. So I thought you were in the other building, but then I checked.
Perfect. That's right in time. That's great. Otherwise, you're losing precious minutes. So this right there. Okay.